Hello, my name is Chuck Williams. I'm an archaeologist and ecologist based in northwestern Pennsylvania. My professional interests include landscape archaeology, forest ecology, and environmental history. My current research focuses in three areas: historic environments of the Allegheny River Basin in northwestern Pennsylvania, the use of LIDAR and remote sensing in landscape prospection, and the archaeology of the 19th century iron industry in northwestern Pennsylvania, a portion of which I'll be talking about today. I currently teach ecology and biology online for Columbia Southern University and have a small environmental consulting business, Williams Ecological LLC. I'm a registered professional archaeologist, and I currently serve on the board of directors for the Society for Pennsylvania Archaeology and the Jefferson County History Center in northwestern Pennsylvania. I'm very happy to participate in this episode of Industrial Archaeology Online. What I'm going to talk about today is some work that I've done in trying to locate relic charcoal hearths associated with the 19th century iron industry at Clarion County, Pennsylvania, using LIDAR prospection. We're familiar with charcoal in varied and sundry ways in archaeology. It's a widespread fuel used for domestic heating and cooking since antiquity. I'm going to focus on charcoal as a fuel in metallurgy, particularly iron production. Of course, charcoal is produced by the controlled combustion of wood. Its value is that it produces a clean, intense heat. It's perfect for smelting many types of ores. It's also easy to transport, way more so than certain types of coal or raw logs or anything like that that you might use for fuel instead. The con is that it's time and labor intensive to produce, so it's sort of an expensive fuel. 19th century charcoal iron furnaces had a heck of a lot of things going on with them, both around the furnace and also out on the landscape. And my interest has always been, as a landscape archaeologist, what goes on in the landscape. So it's not surprising that I'm focusing on the people that are actually making the fuel, the charcoal, to fuel the furnaces from the landscape. But I'm also interested in the other folks that are out there doing things on the landscape, the teamsters that are moving materials back and forth, the ore miners that are supplying the ores needed for smelting, and the wood choppers that are providing the raw wood to the colliers to produce fuels. Now, if you go through the literature, a lot of what you read about colliers is pretty thin in content, and a lot of it's just plain old romantic. As part of my research on the charcoal iron industry in Clarion County, I developed a demographic profile of colliers from 1850 to 1880 using US Census data. I'm not going to talk about that, but if you have an interest in learning more about colliers and who they were and what they wound up doing in the 19th century after the iron industry went belly up, please send me an email and I'll be happy to share a recent paper. Most of the charcoal production in the eastern United States, if not all, was made in open hearths. And most colliers worked in teams of about 3 individuals, where they would prepare a hearth foundation, which is basically a flat stone-free area to ensure even burning. What they produced was a huge amount of wood. On the left here in this image is a hearth that's ready to be sealed with leaves and soil and to begin the charcoal process. That consists of about an acre of wood, which will be about 30 cords or something like that of wood per charcoal hearth. And that produced, depending on the quality of the wood, somewhere between 20 to 40 bushels of charcoal. The charcoal hearths were produced by cut and fill methods. This shows 2 different diagrams from Leonard and Wenstedt. And basically what you have is the upslope area being cut into, the downslope area receiving a fill, and in between is a central platform where the charcoal hearth was produced. Now, Clarion County, Pennsylvania was very important in the iron industry of northwestern Pennsylvania. It had 28 furnaces fueled by charcoal alone, and 3 other furnaces that used bituminous coal and coke. The 28 charcoal iron furnaces were in blast for a span of about 53 years from 1829 to 1882. The average years that a charcoal furnace was in blast in Clarion County was about 16 years. And the peak years were 1849 to 1851, when all 28 of those charcoal blast furnaces were in blast. And as you can see from this diagram on the right that shows sort of the rise and fall of charcoal iron furnaces in the region, it was really a boom-bust type of industry. And there's a lot of reasons for why the industry crashed. And it's probably not just one thing that was a tipping point, but that included things like resource depletion, in particular, the competition for more efficient furnaces in eastern Pennsylvania fueled by anthracite, and also subsidies in the form of the repeal of the tariff of 1842. Now, finding relic charcoal hearths in Clarion County was something that really hasn't been done. There's very little literature on it, and pretty much everything is anecdotal. For example, in this anecdote here from True Tales of the Clarion River, in Highland Township, it was stated that on nearly every farm, here one finds the charcoal hearths. Easy to see as they're graded off level and the earth is black where they were burned. So the key features here is that they were graded to level, which we know from my previous comments of producing these hearths, and that a charcoal layer is present. You can see here a core that I've taken from a charcoal hearth, and my hand there that is covered by charcoal dust, which probably pervaded everything as the colliers worked. Now, when you look through the literature, charcoal hearths look pretty distinct, the relic charcoal hearths. These are all images that are from New York, mostly Connecticut and Vermont. You can see these are sort of convex types of hearth remnants that are present there. And I can tell you, in running around the landscapes of Western Pennsylvania, both bushwhacking, grouse hunting, and all other types of things, I have never, ever seen anything that looked that conspicuous. And in fact, these two gentlemen are standing on a relic charcoal hearth in Venango County, which is adjacent to Clarion County. You can see there isn't really much going on in terms of being obvious or convex. It's basically a very, very subtle type of feature. Now, finding relic charcoal hearths has LIDAR or aerial laser scanning has been widely used, particularly in Europe and Eastern United States, to find relic charcoal hearths. And most of us are familiar with LIDAR. It's really caused a revolution in archaeology, particularly landscape archaeology in the past decade or so. And what's really important when you're prospecting for relic charcoal hearths is what's called the bare earth return, which is basically the ground surface. And you can use that bare earth return to construct digital elevation models, which then can be used for archaeological prospection. Now, the study site I worked at is about a 5-minute drive from my house, so I can be there very quickly. It's Shippenville Furnace in Clarion County. It's located on public land, which is really great, about 3,000 acres. Shippenville Furnace was in blast for about 27 years, from 1832 to 1859. And it was in blast maybe slightly longer than the average furnace in Clarion County. One boon here with the public land ownership is that the forest cover in the area has largely been maintained and not converted to industrial or urban or agricultural uses. The major forest type on the uplands is a mixed oak forest, which is perfect for charcoal production. Prospecting for relic charcoal hearths at Shippenville Furnace, I basically had 3 main goals. Was the first, can we use LIDAR to identify these relic charcoal hearths in the vicinity of this furnace? And then employ ground surveys to confirm or refute those putative relic charcoal hearths that were identified by LIDAR, and then ultimately map the location, document the architecture of these particular relic charcoal hearths. This is a map of the study area, and you can see the public land there blocked out. There are actually 5 iron furnaces within this particular area, so it's a very, very rich area for prospecting. Now, I use an open data, open tools approach to process LIDAR. That's been published by Ben Carter in 2019. Basically, I'm using the open source LIDAR tiles from POSDA, which is Pennsylvania Spatial Data Access. I am improving the resolution of that LIDAR tile using something called LAS tools. And ultimately, I am uploading that into QGIS, which is open source GIS program, and developing slope DEMs. On the left, you can see sort of the standard hillshade LIDAR that you might get from your state access for free, processed minimally. And what you can see on the right is the slope digital elevation model that is produced from that particular hillshade LIDAR. So the process LIDAR imagery of the study area showed numerous circular features, and they were pretty indicative of what other folks were seeing for sort of footprints of relic charcoal hearths in other studies. And so what I did to see if this really was a technique that could be used to locate relic charcoal hearths was to capture the coordinates of 25 putative relic charcoal hearths using QGIS, and then through ground surveys and GPS, I located these relic charcoal hearths, which were confirmed or refuted by soil coring and looking for that charcoal layer. So those 25 putative hearths, 21 or 84% were confirmed as relic charcoal hearths by soil coring. I think in the future, I'll be much better at finding these, and I think we can exceed 95% location and determination of these relic charcoal hearths using LIDAR. The mean diameter of these relic charcoal hearths from the area was about 13.5 meters. They were circular and oblong to platform morphology, and they were largely located on gentle slopes and plateaus, which with a mean slope of about 3.1%. Mean distance to the nearest hearth was about 126 meters. And these white dots here on this LIDAR image show all the confirmed relic charcoal hearths that I've located thus far in the study area. Now, in regards to other studies, what we've determined here at Shippenville Furnace for the morphology and location of relic charcoal hearths fits in pretty well with all the existing literature that's out there for Europe and also for Eastern Pennsylvania, or excuse me, Eastern United States. In prospecting for relic charcoal hearths at Shippenville Furnace, again, I used soil coring to confirm whether a LIDAR image was a relic charcoal hearth or not. The soil cores all showed a single A horizon of charcoal dust and fragments. And this suggests that these hearths had only been fired once. And that's kind of interesting because in areas where the industry has had a much greater longevity, for example, in northwestern Connecticut, where the industry lasted for 150 years, there was reuse of hearths. The site was already prepared. You had charcoal dust there to seal the hearth. It was a perfect thing to do. That did not happen at Shippenville Furnace, at least as far as I know at this point. Now, the length of time Shippenville Furnace was in blast was 27 years. It takes 30 years for a forest, a coppice forest, to regenerate after the first harvest. So there'd really be no time for a second harvest like there would be in some of those areas where the iron industry was of greater longevity. I'm currently investigating the soil chemistry of relic charcoal hearths versus reference soils. I'm not going to say much about that. Obviously, the total carbon is elevated in the relic charcoal hearths, and there's also some evidence for higher soil horizon pH, A horizon pH, and lower values of phosphorus and potassium. Now, future research, what I'd like to do is locate and map pretty much all the relic charcoal hearths that I can find, and also identify and map other elements of the charcoal production complex, including things like haul roads and also collier's huts. The collier's huts are sort of the holy grail of archaeological prospection of the charcoal iron industry. And these are the huts that the crews would stay in while they were tending their hearths. And then finally, to conduct spatial analysis by a GIS to sort of investigate the pattern organization of these charcoal production areas to better understand how they were put together. This image on the right shows some confirmed relic charcoal hearths in red, the red dots there. You'll see a faint trace of an old haul road that's present there. I've been on that road. It's pretty distinct once you're on the ground. But very tantalizingly, there is what I call a putative hut foundation in between two of those confirmed charcoal hearths. So that's a goal for the coming field season, is to get out there and see if we can actually find one of these artifactual charcoal huts. And as an aside, I know Andrew's going to be talking about mining. I also have an interest in trying to locate possible iron mining sites using LIDAR, and there have been some images that look pretty tantalizing, like this one here on the contour of a plateau. And indeed, if you go out and you kick around this particular site, this is a panorama that was taken right in the middle of that mining area. You can see in the center a series of pits. This is open pit mining, relatively small pits that are present. And of course, if you kick around, you start finding some of the artifactual evidence that ties this to iron production, including the burstone ores that were commonly used here, carbonate ores. There's slag that's being put on haul roads to shore them up, and also things like mule shoes that give you some idea of the transportation of products that was occurring in this particular site over time. This was a very, very active area. So later on, if you have any questions, you can ask my Collier technical assistants here to see if we can drum up a proper answer for you. So I thank you for your time.